Hello all. So in the last session we were discussing about how do we implement linear regression using stats, right? So today we will discuss about what we will understand about how do we determine the coefficients and how do we understand the significance of coefficients. Okay. So when we talk about regression analysis, basically coefficient represents the relation between input and output variables. Okay. So when I talk about input, we call them as independent variable. When I talk about output, it is called as dependent variable, right? So these coefficients will actually gives us the relation between x and y, that is dependent variable and independent variable. Okay. Now the interpretation of the coefficients depends upon the type of regression model we choose. For example, when I talk about linear regression model, okay, so these represents the change in the independent variable for one unit change in the independent variable. For 1 point of dependent, how is my, for 1 point of independent value, that is x, how is my output getting changed? For example, when you see, if the coefficient of variable x1, I have 10 values x1 to x10. Okay, so if the coefficient of a variable x1 is 3, it means that for every 1 unit increase in x1, the dependent variable y also increases by 3 units, because I am having the coefficient is 3, right? So when I change that particular value, my dependent variable value also gets changed. Okay. Now when we talk about logistic regression, that is another type of regression model. Here we basically use log odds method, which we will discuss in the upcoming sessions or probably in the next session. Okay. Here these coefficients, the coefficients in logistic regression actually represents the outcome of the log odd. Okay. So the coefficient here actually is used for interpreting the results in terms of probability. Okay. So when we talk about logistic regression, it's all about non-linear data. Okay. When we talk about non-linear data, we go for log odds method, where we want to calculate the probability. Okay. So hence we say the interpretation is done based on the probability. So the coefficient term is based on the probability. Okay. Now when I talk about another polynomial or nonlinear method, so here we use different powers of the dependent variables. Okay. We have curve like relation between predictors and outcome, that is input and output variable. So depending upon the type of regression model we choose, we have different coefficient values. Okay. Now let's talk about linear regression. Okay. So in regression model, basically the coefficient will give you the relation between input and output as discussed. Okay. Now let's take a simple linear regression. Okay. So here I have y, which is my output variable. Here I have beta naught plus beta 1 x1 plus beta 2 x2 plus beta n xn plus epsilon. Okay. So here x1, x2, x3, x4, x5 or till xn are inputs. Different types of features in the input, different input variables, and y is the dependent variable or the output. Here beta naught represents the intercept. Okay. And this error term is randomly added for variability. Okay. So here the coefficients, when you observe the coefficients, beta naught, beta 1, beta 2 will actually provide the expected change in the slope. Okay. Because that is the intercept. Okay. Now when you talk about logistic regression, as I was mentioning about, here we have the binary outcome, yes or no. So depending upon the probability of the values that we get in x and y. For example, if I go for prediction of a cat or dog, if I have x as 0.7 probability, y as 1 to, for cat and dog, different probability values. So the higher output value would be taken as the final output. Okay. So depending upon the success, failure, yes or no. Okay. So depending, yes or no, fail or pass. Okay. COVID is there or not, cancer prediction is there or not. Okay. Yes or no. So depending upon that, we will go for logistic regression, where we will apply log odds ratio, probability of the event occurring basically. So here in this case, the coefficients are calculated with logarithm of p by 1 minus p. Okay. P represents the probability of the event which is occurring. Okay. Now when you talk about determining coefficients, how do we determine these coefficients? Okay. So when we talk about determining coefficients, it actually involves estimating them from the data. Okay. So we can use different optimization techniques or different methods with which we can determine the coefficients. So one such is OLS method, ordinary least squares, which we have used in the last session when we were talking about linear regression using stats model, OLS method, right? So when we talk about OLS method, basically it is the most commonly used estimation methods for linear regression, and here we will actually calculate the coefficients by subtracting your predicted values with the actual values. Okay, the reason why I am taking square is because I may also get negative values, because the prediction values may be either below or above the required values. So in order to avoid that, we go for squaring. Okay, so sum of squared residuals. Okay, so this is how we calculate the coefficient. Okay, what will be our ultimate aim here? To reduce the loss. Okay, see, if suppose I say I want 70% pass percentage for my section. Okay, this is my actual value, 70% expectation. Okay, but this is my expectation. Okay, but if I get only 30% pass percentage, okay, I am not satisfied with that result. So 100 minus 70 would be 30. There is 30% difference, or 70 minus 40 is 30%. 30% difference about what I predicted and what is the actual output. So if I get 70% pass percentage, my expectation is 70, pass is also 70. So I've got good accuracy, that is 100% accuracy on my prediction, right? So the main aim would be here to reduce the difference between the actual value and predicted value. The more the difference, the less the accuracy. The less the difference, the more the accuracy. Okay. Now when you talk about second different method for defining or determining the coefficient is MLE. One is OLS, which is the most commonly used one, and the second one is MLE, which is nothing but maximum likelihood estimation. Okay, so we use OLS for linear regression, we use MLE for logistic regression. We have three types of regression models that we were talking about, right? Linear regression, logistic regression, polynomial regression. So we use OLS in general for linear regression. We use MLE, that is maximum likelihood estimation, when we talk about logistic regression, where log odds are used. Okay. Now, what are the significance of these coefficients? As I already told you in the last session, so we can find p-values, we can find t-tests, we can find confidence intervals and all that. Now let us see what is this p-value and what is the significance of that particular p-value. Okay. Now our major concentration is on t-test. Okay, I'll tell you about t-test later, but first of all let's concentrate on p-value and confidence interval. Okay, the p-value will actually tells whether the coefficient is statistically significant or not, whether that is actually helpful or not. Okay, now a low p-value, that is less than 0.05, means the coefficient is significantly different from 0, indicating that the independent variable has a meaningful effect on dependent variable, that is X has meaningful effect on Y, that is they are highly correlated. The low value of P says more dependency of Y based on X. Okay. Now when we talk about confidence intervals, they will actually provide the range of values within which the true coefficient is likely to fall. If the range doesn't include 0, the coefficient is considered significant. Okay, so these two are the importance or significance of coefficient p-value and confidence intervals. Okay, now the main points when I talk about coefficients. Okay, coefficients, how do we generate these coefficients, what is the significance of coefficient? There are three things. First is magnitude, and then sign, and then the statistical significance. Okay, so when I talk about magnitude, which actually indicates the relation between input and output, that is strength of the relation between input and output, how well they are bonded together, much dependency or no dependency. Okay, suppose X, when we talk about some examples, let me talk about some examples. The more the percentage of attendance percentage of the student, the good the result is, because he is coming to the classes regularly and then he is obtaining good results. This is perfect correlation between X and Y. But sometimes in some cases, even if they don't turn up to the classes, they pass well, right? So this is the case of discrepancy. Okay, so that would be determined by magnitude, how strength is the coefficient based on input and output dependency. Okay, next is sign, which indicates the direction of the relationship, whether if input is increasing, output is increasing or decreasing. Sometimes with input increasing, output also increases. With input decreasing, output also decreases or increases. So this is represented by sign. And then finally, statistical significance, which will tell us whether the relationship is likely to be genuine or due to chance, whether randomly they are arranged, X and Y are randomly generated, or whether they are actually dependent or not, significance of that particular input. So sign, magnitude and statistical significance are the key points that comes into picture when we talk about coefficients. Okay, coefficients are nothing but the values which will actually gives us the relation between input and output. All this we are discussing because when we want to go for implementation of linear regression with machine learning, we directly use the model functions which are available in the libraries. But before we actually develop machine learning algorithm for regression, we also have to understand about the statistical analysis and the coefficient calculation and significance of the coefficients. So that's all for today. Thank you.